Hi, my name's Grayson.
Hi,
Very
I'm
nice
sorry, I'm
to
trying
meet
to
you.
shake hands just
it's
to be a little
okay.
more germ conscious.
What is our exercise 00? I went to click on it on Gradescope and then it just
Yeah,
gave
so it's
me-
on the course website. So if you go to the course website and click on Exercise Zero, you'll see the write-up instructions.
Where is it on the website?
It's on the home page.
Really?
So, hold on, I can just pull this up.
Because I looked, I didn't really see it.
So, right here, Exercise 00, Hello World.
Oh, okay. Oh, is it something for today?
It's released today, but it's due Tuesday.
Okay. I thought...
Oh, so yeah, maybe you looked on Monday or something and I hadn't released it yet.
Okay, thank you.
Yeah, no problem. I guess we can get started. All right, hello. All right, let's go ahead and get started. So today we are going to be learning about objects and data types. So they're a very fundamental type. This is really loud. They're a very fundamental aspect, building block of coding. But before that, I wanted to make a couple announcements. So there are, I just want to make a few notes about just accessibility things for the class. If you do have to be absent for whatever reason, I don't make attendance mandatory and I do record lectures. However, we do kind of limit sharing those recordings for like special circumstances. Or if you're only absent a couple times this semester, we'll share the video with you, no problem. So if you ever are absent and you need a lecture recording, just email Comp 110 Help and they will send you that recording. We also do have an accessibility lead, Carmine, who's actually here today. Carmine, wave. He really takes care of a lot of like your accessibility concerns. So he's just a good point person to talk to if you have any other concerns. Like obviously, like most things are handled through ARS and built into the class. But if you have any extra concerns or anything special you think we could add to the class to make it more accessible, please let us know. Also, if you are taking all of your, if you do have extended time or anything like that for your exams, make sure you book all of your quizzes and finals with the ARS Testing Center, and I would just go ahead and do all of them today. All the dates are on the syllabus, so I would just book all of them today. We can't have it in this classroom because there's classes before and after, so we can't give extended time for in-class exams. So you have to take it through the testing center. Any questions about any of that? All right. And then I also just kind of want to talk about like my general idea for the structure of this course. So the most weeks will be structured where Monday is a little more lecture-y, where we'll be learning new concepts. Wednesday we'll be doing a little more conceptual practice of those concepts, so it'll be more pen and paper and like thinking about them more like analytically. And then Friday we'll be doing coding, trying to implement those new concepts. That being said, this week is pretty much lecture-y the whole week, just because we have a whole lot of initial things to learn off the bat, and then next week we can kind of start with our more classic class structure. So what I wanted to start with today is intro to the workspace you're going to be using. So some of you have already done your setup for your course workspace, which awesome, that's amazing. And if you haven't yet, that's okay. I just kind of want to show you like this is what you'll see once you have done the course setup, and to kind of just introduce you to it and kind of get you a little more familiar with Visual Studio. So I'm going to go ahead and open Visual Studio. And when you open your workspace, you should see something like this. So I do have my container open. So if you've done the setup, hopefully you're able to open your container. And let me delete that. And you'll kind of see these three main panes on the screen. You'll have on the very left, you have these basically it's just your files. So this is just a file organizer. So this is under the Explorer tab. And you'll see these are just all of the actual files that you have in your workspace. So as you add new files, you'll see that, they'll show up. There are going to be some existing. Yours isn't going to look exactly like this, but it should look pretty similar. So like you'll already have a folder for exercise 7 because we gave you some files to start with for exercise 7. Things like that. So these are the kind of things that will pop up once you have your workspace set up. And again, you can like add files, delete files, all that. And if you want to kind of view a file, so if you wanted to say I have this file and I want to view it in my system, you could right click and show in Finder, I think it is. I think you have to actually do that outside the, never mind, you have to do that outside the container, so it's a little harder. But these are all like files that are just existing in your computer, in your local files. Now, this pane is what you use to actually edit those files. So the center top part is how we edit those files. And so let's go ahead and create a new file. I have a lessons folder here. If you don't have a lessons folder and you're following along, you could right click and do new folder, and then just name it lessons. And I think in general, it'll be good to have a lessons folder because, it's just, anytime we work on code during lessons, it's a good place to save them. And then I'm going to right click on lessons and do new file. So I'm going to create a new program. I'm just going to call it first program. So first underscore program. It's a common convention to use underscores instead of spaces. And then I'm going to finish it with .py because it's going to be a Python program. So it needs to end with that .py. And so now I've started that file, and you see it's kind of opened the file here, and now I can edit it. So this is just a text editor, just like Microsoft Word. It's just this area, you're just editing the text in the file and saving it. For Python, we call these files modules. So you'll often hear that interchange, like the file versus the module. Those are kind of interchangeable. And so this is where we can actually write our code. So one command that you'll learn pretty soon is print. And so that's a very common function, and it'll just print out whatever you tell it to print out. So I'm going to use quotes to say it's going to be quotes in Python denote something's going to be a string. And I can go ahead and say whatever I want. So I can say howdy. And then I did Command S to save, but you could do File, Save. And now I've just written a program and saved it as this file. Now it's saved under the file name firstprogram.py, and then this is the text of my program. So if I wanted to run this module, I could do that in my terminal. So this down here is my terminal. If it's not already open, you could go terminal in your top menu and do new terminal, and it'll open a terminal for you. And the terminal is just a way of interacting with your computer. So this is just like the command line app that you have on your computer, and like the thing that like you see all the hackers typing into in like movies and stuff. That's what this is. This is your command line. And basically it's just another way of interfacing with your computer. It's a way of interacting with your computer, but you're doing it all through text commands. So if I wanted to like see what file, where I was, like what folder I'm currently in my terminal, I could type in this command, and it'll say, okay, you're in your workspace. Or if I wanted to see what files are in my workspace, I do this ls command, and it'll list all the files in my workspace. You don't need to know these commands, but like just the general idea that this is just interacting with my machine. And so a good command to know, though, is clear, because it'll clean out your terminal for you, which is nice. So if we wanted to run a program in our terminal, I tell my computer, find this file and run it as a Python program. I first use the word Python, and then I say -m because I'm running a module. And then I want to give it the path to wherever this program is. So it's inside my lessons folder. So I say lessons dot, and then the name of my file, first program. And if I hit enter, you'll see it printed out howdy, because that's what I told it to do, was to print out the word howdy. So we just ran our first program. Oops. So that's one way you can run a program. Another way you can run a program is using your trailhead. So this is something that is a nice feature of this container that you have. So if you see this little play button with the little bug next to it, that's your little run and debug option. You also could click on that, and then you see this little play sign here next to start trailhead. And if I press that, you'll see some stuff starts happening in my terminal. And it's basically starting up my trailhead. And you'll see something like this where it gives you a location of where your trailhead is. And then you might get a pop-up, or you could just copy paste this URL into your browser. But you might get a pop-up that says open in browser. And something like this will open. And this is all the files I just had. So these are the folders that I just had in my in Visual Studio. And so remember, the program I just wrote was inside my lessons folder. So if I click on my lessons folder, there it is. There's my first program. So if I click on it, it should automatically run my program. So it did. It ran it. It said howdy. So that's another way you could run a program, is using this trailhead right here. And we do have this other tab that says interact. I'm going to just tell you not to worry about it too much this week. We'll learn how to play around with that next week. So just right now, focus on this run tab. If I click it, it'll just refresh and run the program again. And then I can click on trailhead to go back. And then I can do it for other things too other files I wanted to click on. So any questions so far? So there's just two different ways to run a program. Yeah?
Where do you go to get to Trailhead?
To get to Trailhead, you go, so you should have your container running. So it should say something near the bottom that says like dev container. And then you just press the little bug with the debug button on the side. And then you'll see this little plus sign that shows up here. And you want to press that. Cool. Any other questions? Yeah?
How do you add a folder?
You just want to go back to your Explorer and just right click, and it should have a new folder option. Are you just stretching? I think they're just, okay. Any other questions? What? Yeah, if you right click inside this part, like this pane here on the left, just kind of right click under the file names, and there should be a new folder. Like this should pop up, and then there should be a new folder option. And then similar, if you want to create a new file, you right click and you do new file. And we kind of like reiterate these things in the exercise instructions. I just wanted this to be like, so you can like see a demonstration of someone doing it. But we really step you through it with exercise 0, so you can kind of see these steps. All right, any other questions before I continue? Yeah. How do you add Python to what? Did you do all the course setup? Did you finish your file with a .py, your file name? That might get you. A TA can come help you if you raise your hand, if you want, or you can ask TA. It's hard for me without looking at your computer. Ivy? Ivy? Psst, hey, Ivy. Can you help the person who has their hand up, please, in the center?
Oh, yeah, I got you.
That's okay. So, I shouldn't let you all sit next to the puppy. Anyone else have any questions? Yeah.
I have created a file, but it's not a Python file. It's just a file with.
You can rename it. So you can right-click rename, and you can just make sure you add that .py to the end. All right. So okay. So those were two ways to just create. Yeah. Go ahead.
Will it do this in the terminal and it says command
That means your setup's probably not fully done. So you want to just go to the open house and make sure that all of your setup's done. All right, so yeah, so okay, if I want to close the Trailhead server, I would just do Control-C. And you'll see it kind of gives me back this interactive part of my terminal. And I want to show you another way you can do write a Python program. And this is more like if you wanted to kind of just do things quickly. So I'm going to type clear. And what I'm going to start is called the REPL. I'm not actually hitting enter on that. I'm just typing out so you see how it's spelled. And REPL stands for read, execute, print, loop. So it's basically a loop where it'll read your code, execute it, and print out the result to you. And so the way you start your REPL in your terminal is you type the word Python. And you'll see these kind of like, it'll say, start this Python, and then you'll have these little arrows, and it'll be waiting for you to type something. And now you have this interactive environment where you can type, you can write programs, and so this can be helpful if you want to just like do a quick computation. So if I say I want to do like 1 + 1, you'll see it'll simplify it and give me back 2. Or if I wanted to print something, like print out howdy, it would print it out for me. So that's fine either way. And so yeah, so it's another way to kind of run Python commands. But notice like none of this is going to be saved. So once I can exit my REPL by typing in quit with 2 parentheses. And once I exit my REPL, none of that's going to be saved next time I open up Visual Studio. So none of this, like it won't remember the 1 + 1, it won't remember the print howdy. So this is more if you just want to kind of do quick computations that you're not saving. And so this can be kind of helpful when we're learning new concepts, just to kind of test out different things. You'll notice in this lesson we're going to do today, in the first section I got a lot of like, well, what if you did this? What if you did this? And that's what the REPL's helpful for, because you can just very quickly type in like, okay, what if I did this? Instead of like editing a file and then saving it and then running it, you can just kind of type it in directly to your terminal. So any questions about that? And all of these are kind of explained a little more in the lesson on Gradescope. So you can definitely refer to that. I just kind of wanted to give some visuals. Okay, so now I want to go to the main part of our lesson today, which is objects and types. So an object is just a unit of data in memory. So like the number 1 is an object. The word howdy, that was an object. And every object has a type. So 1 is a number, right? Specifically, it's an integer. So in Python, it's an int. The word howdy in Python is considered a string because it's a string of letters. And we'll talk more about those specific types. But every object has a different type in Python. And it basically tells Python how to interpret that object. So, you know, if it's a number, then I know I can do things like add with it and multiply with it. Where if it's a word, you know, I might want to do other things instead of multiply with it. So that's kind of that's kind of the idea behind knowing what type your object is. And so there are different types. I talked about, so numerical, like the number 1, but also could be like your decimals. Textual is those idea like strings, so words or sentences. Sequences. So technically a string is actually a sequence because it's a sequence of letters, but we'll talk more about sequences. Or you can make types of other types, which we won't talk about today, but it's just something you might see in the future. So for your numerical built-in types, and also all these slides are on the website, so I just sometimes see people like rapidly typing along, and all these are on the website, so hopefully you have access to that. Okay, so your first numerical type is going to be your integer. So that's what I kind of hinted at. That's your whole numbers. So they could be positive or negative, but they're whole numbers. And in Python, it's denoted using the keyword int, int, all lowercase. And so it's just a 0 or non-zero digit followed by 0 or more integers. So an example is 100. Another example was the number 1. Now, we still do live in a world where decimals exist, so we do have to have a type to handle that too. And so in Python, we handle decimals with a type, they're represented in a type called a float, or a floating point number. And the keyword for that in Python is all lowercase float. And it's not the only way to represent decimal numbers, but in Python it's the most common, and it's a very precise way to do it. So those are two of our numerical types, and so I kind of want to just show you what that looks like in our workspace. So I'm going to go ahead and start my REPL again. So let me first do clear Python. Okay, so again, a numerical type could just be the number 1. If I just type in the number 1, it'll just say, okay, you just gave me the number 1. I evaluated that. What's nice is there's this function called type. And basically, as an argument to the function, you can put whatever object you want to know, like what its type is in Python. So if I want to say what type is this number 1, it'll say it's an integer, which is what we expected, right? 1 is an integer. Now, if I wanted to check the type of 1.0, you'll see that's a float. So it says, okay, that has a decimal point, so that's going to be a floating point number. And you can do different things with your numerical types, right? Like I said, you could add them. So you do 1 and 2 are both integers, so I can do 1 plus 2, and it'll give me 3, things like that. We'll talk more about that in terms of, that's an expression, 1 plus 2. So we'll talk more about that on Friday. But this is just the basic idea of your numerical types. Any questions? I can leave this part. No? Okay. Now, one thing I also demonstrated was a textual built-in type. So those are your words or your sentences or just letters. So the textual built-in type in Python that we use they're called strings. The keyword in Python is str. And it's just a sequence or string of characters. So the example that I gave in was the word howdy, right? So the word howdy is a string. And so strings are usually denoted with these double quotes on either side. You'll notice it gives it back to you with single quotes, and that's okay too. You could theoretically do it with single quotes if you wanted to, but in general, in this class, we like to use the double quotes. And if you wanted to check the type of howdy, you'll see it says it's a string. Now, let's say I just wanted the first letter. I just wanted just the H to print out instead of the whole word of howdy, right? Because when I type this, it prints out the whole word, howdy. So maybe I just wanted to print out the letter H for some reason, or wanted to access, I just wanted to know what's the first letter of this. And so if I wanted to do that, I use indexing. And so basically that lets you access only certain, a specific element in your sequence. And so the type of syntax that we use to do that is called subscription syntax. And it's using square brackets, which I'll demonstrate in a second. But it allows you to access an item in a sequence. Whoever's can we keep it a little quieter? Sorry, thank you. Okay, so indexing starts instead of, so even though I know we're normally counting, we start at 1, right, if we're counting things. But what's kind of interesting about coding is our indexing starts at 0. So what I mean by that is if I wanted to access the letter H in howdy, I would type in the word howdy, and then in square brackets, I would put the number 0, hit enter, and you would see the letter H. So the 0th element is H. If I wanted the letter O, I would do 1, give me O. So the indexing starts at 0 to get the very first element, and then it increases. Does anyone know why that might be, why coding is that way? They start at 0 instead of 1? No? any like intuition, I guess not like know why, but any intuition why that might be? Yeah. Yeah, yeah, so exactly. So in binary, which like, you know, computers are fundamentally zeros and ones, true, false, like transistors going on and off. And so basically in representation of numbers, we use binary representation, which starts at 0. And the big issue with computers was when we first created them, memory was really limited. And so if I was going to start counting at 1 and I'm just not using the number 0, then I'm just like have this wasted representation. Like I have this 0 that could mean something that I'm not even using. And so that's why they're like basically like we need to use every single number that we have for every representation because we only get like so many numbers. And so that's basically the idea behind it. So they wanted to start at 0 so that we can have as many representations as possible. That's kind of my lazy explanation of it. So yeah, so that's the idea of why we start at 0 for our indexing. And again, this lets us access things. Any questions about indexing? So if I were to do the string 1, 2, 3, 4, right? So it's just a string of number. It has integers in it, but it's a string. It's 1, 2, 3, 4, and it's in quotes. So if I were to do 1, 2, 3, 4 at index 0, what would I get back? And what type would that be? String. Raise your hand if you think it'd be a string. All right. Raise your hand if you think it'd be an int. Raise your hand if you think it'd be something else. So yeah, let's go ahead and try. So let's see what the type is. All right, let's do this. We'll call type of this. So that's the type of our return value. It's a string. So since this element is technically, if we access it with a 0 index, it returns 1 as a string. And one way that's kind of giving us a hint that it's doing that right is it put the little quotes around 1. Because remember, if we just do the number 1, it doesn't put quotes around it. So if it's an integer, they wouldn't put quotes around it. Any questions? Yeah.
So for this, like the indexing, that's only for the string, like not another type of.
Yeah. So far for there will be other things you can use indexing on, but we haven't learned them yet. So far indexing only applies to strings right now. Yeah, so you don't want to do like indexing on like integers. So I don't want to do like 123 at index 0. It'll give me an error. It'll say something like, it's not subscriptable, so you can't use subscription syntax. Okay. All right, so another type of string I just wanted to introduce is the idea of a docstring. And this is a very specific type of string. Instead of single, like you just have your regular quotes, you have triple quotes on each side. And these are very specific strings meant to kind of explain to you. They're meant to document, hence the name docstring, what your code is doing. So they're more for the reference of you if you're going back to look at your code, or someone else if you're sharing your code with them. So like say I wanted to open this program, and I'm like, okay, I wrote print howdy, like, why am I doing that? Or like, what does this program do exactly? So I just want to this is a pretty simple program, so I think we can all tell, okay, it displays the word howdy. So, but as your programs get more complicated, it's helpful to have this docstring to kind of tell you what your program does or what you were trying to do when you wrote it. So I could write something like, greet you in a southern way. So that's what this program does. And then I'll save. And so now if I actually did start my Trailhead again, so let's go ahead and start our Trailhead and run this program again. So if you remember previously, it would just print out the word howdy for us. Why is it giving me? Oh wait, I have to exit out of my REPL? There we go. So I typed quit to exit my REPL, and then I started my Trailhead again. And so you'll see that lessons, remember, is in our lessons folder is first program. Now you see the docstring showed up here. So it's going to tell me what the program does. And then when I click on it and it runs the program, it just prints out howdy. So it didn't change what actually happens when I ran the program, right? It still just prints out the word howdy. It's just for that documentation so that I know, looking back, what that program does. So that's a docstring. So the next type I want to talk about is called a Boolean. And a Boolean is denoted in Python with the term bool, the keyword bool, B-O-O-L. And a Boolean is something that evaluates to true or false. So this can be helpful if you're trying to really like make decisions in your program, because you could say, you know, I only want this to happen under these certain conditions. I only want to run this program under certain inputs or whatever. And so you want something to check if something is true or false. And so a Boolean lets you do that. So in our REPL, so I'm going to go ahead and stop my Trailhead and go back to the REPL. So again, I type in Python to start my REPL. If I wanted to do a Boolean, true is a Boolean. It just means something's true. And false is a Boolean. And they are case sensitive, so they have to have the capital T and capital F. And so if I wanted to check the type of one of those, false, you'll see, okay, that's a Boolean. But certain expressions also evaluate to true or false. So if I say I want to check if 1 is greater than 2, that's false. So I want to check the type of 1 is greater than 2. You'll see that it's a Boolean, right? Because it evaluates to false, and false is a Boolean. So that's all a Boolean is. It's something that evaluates to true or false. We'll get more practice with that when we, actually need to use it, but it's helpful for kind of making those logical decisions in your program. Any questions? Yeah.
Could a TA help me super quickly?
Sure. Carmine, would you go? Can you put your hand up and Carmine will help you? Okay. Anything else? Alrighty. So a few other just useful functions to know. You've seen me using this type function, which just checks an object's type. So if I say type of something, whatever that argument is, it'll just tell me what its type is. And you also can change an object's type. So you can convert it from one type to another. So say I have a number that's an integer and I want it to be a float. So say I have 1 and I want it to be 1.0. I can convert it to a float just using that keyword with parentheses. So what I mean by that is, say I have the number 1. You'll see if I check the type of number 1, it's an integer. But what if I do float of 1? You see it converts it into a float. So I can actually use the keyword float with parentheses to convert 1 into 1.0. And I can even check the type. So type of float of 1. You'll see it gives me a float. And I also can do it between like numbers and strings. So say I have like int of the string. So let's say I have the string 1, 2, 3. Right, so that's a string technically. So if I check the type 1, 2, 3, that's a string. But say I do int of 1, 2, 3, you see it converts it to an integer. So we can check the type of int 1, 2, 3. You see it made it an integer. So that's just a helpful sometimes you'll have to convert things to like from floats to integers, things like that. Any questions on that? Pretty straightforward, I think. All these things we'll get more practice on. Okay, so let me double check how we are on time. Okay, perfect. All right, so I wanted to switch gears here and finish what I was wanting to talk about on the first day of class. And And this is more to just give us, again, like a more conceptual introduction to this course in general. So this will give you some context to kind of frame this course around, and give you like a soft introduction to some of the concepts we'll be talking about. So we did talk about an algorithm, right? And that is just something that gets input and returns a result. And the algorithm is just the set of steps. And we talked about some examples of everyday algorithms that we use to solve everyday problems. Does anyone have like a particular example they liked from that you can think of? I just want to have something to reference. I'm trying to think what they were. I get the sections mixed up. All right, well, I'll go with my example that I remembered from a previous section, which was like someone's workout regimen. So like that's your algorithm is like how you decide what your regimen's going to be. So the input could be like what machines are available at the gym. The input could be whatever like your fitness goals are. And so your algorithm is choosing like which machine to work out at which time, the order in which to do it, how long, how many reps to do, all that. And so obviously your immediate result is being tired and sweaty, and your hopefully long-term result is to feel good about yourself and feel healthy. So an algorithm is just a set of steps to solve a general problem. Now, an algorithm should be finite. It should always complete, but it should be able to handle a problem of arbitrary size. So I know those two last bullet points sound a little contradictory. So does anyone feel like they understand the difference and can explain it? No, maybe. Okay, so basically the idea is, it's okay, in the first section, no one raised their hand either for this one. So the idea of finite is just that it completes. There's always going to be an end result. So for the workout problem, you're not gonna work out forever, right? Like indefinitely, and you're not just gonna stand at the gym and stare at machines for the rest of your life. Like there's gonna be some action taken, then it's gonna be completed. And so that's the idea of finite. But what I mean by it can handle a problem of arbitrary size is you should be able to handle it if there are 2 machines in the gym versus 100 machines in the gym. So you might have a lot more options in one, and so your result might change. What you choose to do for your workout might change, but you still have some algorithm in your mind of given how many machines there are and how many are available, this is what I do. So again, the arbitrary size is just like, it could be a gym with a ton of equipment, or it could be a gym with 0 equipment, or like a couple things. And your algorithm should theoretically work in either gym. So a very classic example in coding is this idea of finding the lowest card in the deck. It's not a very exciting example for an algorithm, but it's really the bread and butter of coding. It comes back as a good example, I think, for a lot of other concepts. And this is also just considered a classic search algorithm. You're trying to find the minimum, the smallest item. And so say I wanted to generalize this into an algorithm. I just did these 2 bullet points to kind of say, like, this would be my algorithm. If I wanted to explain someone of like how I wanted them to do this, this would be the algorithm I would give them. Go from left to right. Remember the lowest card you've seen so far and compare it to the next cards you see. So what I mean by that is I would start at 5. The first card I look at, so far, as far as I know, that's my lowest card. Then I look at 2, okay, 2's less than 5, so that becomes my low card. I look at 3, okay, 3's bigger than 2, so I don't need to adjust anything. Look at 5, okay, 5's bigger than 2, I still don't need to adjust anything. And now I've looked at all the cards, and I've found my low card. So it's kind of the idea, like this is my algorithm, these are the steps I take. So let's go a little more in depth on what's happening at each step. So again, I start with just the first card and make that my low card. I look at the second card, and then I'm doing this comparison. I'm saying, okay, is 2 less than 5? And it is. So then I update the low card. Then I check, is 3 less than 2? No, it's not. So I don't update my low card. I check, is 5 less than 2? No, it's not, so I don't update my low card. So this idea, so what I'm doing right here is I'm comparing two numbers, right? And so this is called a relational operator. And I don't expect you to know like all of these terms today. These are all things we're going to go in depth more on. I just kind of want to give you like some context of like where you'll see them. So this is my relational operator. I'm comparing how two numbers relate to each other. And then I also want to say this idea of like changing my behavior based on like whether or not, so like 2 was less than 5, so I updated my low card. 3 wasn't less than 2, so I did not update my low card. That idea in coding is called a conditional, because I do things only under certain conditions, and I'll come back to that. So another thing I wanted to hit on is this idea of pseudocode. Pseudocode is basically something that looks like code, but it's more readable. And the whole idea is like, you write it out more so you can kind of trace like high level what your program's going to do, but not like in depth what your program's going to do. So if I were to actually try to like run this as a Python program, it wouldn't work. It's not like an actual functional program, but it looks kind of like code and it's laid out like code. So it's easy. It's another step towards translating it to code. And it's helpful when you're trying to kind of come up with a more complicated program and you want to kind of think, okay, these are the steps I would take. You can kind of write it out in pseudocode first and then think about like, okay, now how do I get this pseudocode to actually be something that would like run in Python? So say I wanted to convert this very complicated bullet point algorithm here into pseudocode. I could say something like, okay, I'm going to have this variable called lowest card. And lowest card is going to be my first card in the deck. So that was when I looked at, 5, that was first card in the deck. That's my low card, right? And so this is called an assignment operator, because I'm basically saying, okay, this lowest card, I'm assigning it the value of 5. It's going to be whatever the first card in the deck is. So it's getting assigned a value. And then the rest of my code could look something like this. Repeatedly until the end of the deck, if the card I'm looking at is lower than my low card, that becomes my new low card. So what does that mean is like, I look at the next card, like I look at 2. 2 is less than 5. So since 2 is less than 5, then 2 becomes my new low card, right? So, and then I do that for every card. So then I say, okay, is 3 less than 2? No, so I don't have to do this update. And so that's this could be my pseudocode. This could be my program. And so this idea, notice I didn't say like do it 4 times because we had 4 cards in the deck. I just said do it repeatedly until we get to the end of the deck. And so the idea of this is called a loop. Basically, it lets you perform an action repeatedly an arbitrary number of times, whatever the size is that you set for it to do. So it'll help you repeat that action. So here it will repeat it until there are no cards left. And so that concept in coding is called a loop. And then again, what I talked about was this idea of like your program doing something only under certain conditions. So only if the card we look at is lower, that becomes our new low card. That's our conditional statement. So if we find a lower card, then I want to update it, update my low card. And again, I just wanted to point out that relational operator is popping up in there. Now finally, say I wanted to generalize this for any deck, because theoretically this should work for any deck. I say repeatedly until the end of the deck. So it should work for 100 cards, it should work for 2 cards, whatever. So I could define this as a function. I could call it find low card, where I input a deck. So similar to how we were calling the function type and we input, the object we want to know the type of. We do find low card and we input deck, the deck of cards that we want to find the low card of. And then it should generalize now for that specific deck. It'll do it for the first card in that deck and find the lowest card of that specific one that I input. So the idea of this is a function. That's what we would call it in programming. We write a function that basically has this general structure, but it could take an input, take different inputs and give you results specific to those inputs. So those are just some main takeaways. So like a high level idea of those words, of those terms. But again, all of these, we might not go too much more into pseudocode, but otherwise, and you don't really need to implement it on a quiz or anything. It's just a helpful tool when you're writing code. But all these other concepts we'll go more into in class. And so I just kind of wanted to have like a frame of reference for that. And so we do have 5 more minutes left of class. You are free to go if you want, but I would recommend starting the lessons on Gradescope, especially since we're here to answer questions if you have them. But otherwise, I'll see you on Friday.
I'm not sure if you can help me out with this. I've been trying to do the installing a Windows subsystem for Linux. It will not let me.
Okay.
At least, so I had already done it on my. I have a PC in my dorm, but I have the laptop as well. It was fine on PC, but I've been having this happen. So.
Interesting. Yeah, did you try going there?
Yeah, so I tried going there. Didn't help me too terribly much. Because,
Okay, so you could copy this command, but you want the name of the machine to be that argument right there.
right, and how would I figure out what the name is?
Let me see the instructions. Where was the terminal? Oh, here it is. Virtual machine platform, Windows feature, I wonder if we just did that WSL. Let's see what that doing here. What does it do? Set VM process. This is specified that my class on computer was made. Hey, what's up?
Do you know where it says to tell them to install Python in the Comp110 site?
It should be like once their environment is installed, so like once the container is built, it should install Python like in that container.
I've had a few people with an issue where like it isn't installed like on their computer at all.
Maybe is their container not open? They have to open the container,
Oh.
and then Python should be there. All right, let me go back to this and read this feedback again. See, I don't know off the top of my head. I would recommend going to open house,
Yeah.
and they'll have like more time to dedicate and figure it out for you. And if they don't, then they'll send it to me, and I'll have more time to plug around with it later.
Worst case, I do have it on my PC in my dorm,
Okay.
so I wouldn't be able to use it in here, which I don't know. If
Yeah,
often-
we have alternatives if you can't. So if it absolutely doesn't work, we'll have our alternative for you.
Thank you.
Yeah.
So when I was at the syllabus and then I went on Gradescope,
Uh-huh.
and then it took me like immediately to this quiz, and then I just X back, but then it like submitted automatically, and I didn't answer any of the questions.
It
Am
should
I
be.
allowed to,
Yeah,
like,
I think you can submit as many times as
resubmit?
possible.
Oh, okay.
So yeah,
I'm
it
safe.
shouldn't be an
Okay,
issue.
thank you.
Is anyone? So I'm doing non-setup issues. Any non-setup issues? Okay.
I just had a quick question about the syllabus.
Yeah.
So for the lessons, can we resubmit until the due
Yes.
date? Okay.
Yeah, everything you can resubmit until the due date. The only
Okay.
thing not is quizzes.
Okay, and also challenge questions. Are those like random? Because I was looking through the schedule and I didn't like see any like pinpointed. Like
They're not random. I mean, what do you
are
mean?
they like just like are they, I'm just like confused with challenge questions.
A challenge question is just like a small coding problem that we'll do in class.
Oh,
So I
okay,
think our
okay.
first one's like next week.
Okay, cool, awesome.
Yeah.
Thank you.
Yeah.
question about the syllabus. Like, I started it yesterday, but then it like submitted even though I wasn't here. So
Okay,
is
you
there,
should be
like,
able
a
to
way-
resubmit, right? Or
Okay, because how do I like change my answers to like I can't fill out any of the questions I didn't answer. Like I think I got halfway through.
can
it.
you refresh it and see? Hold on, I just want to see
Yeah,
something.
it's just weird because I didn't I got like halfway through it and then I was saving the rest for today
Right.
and then I just submitted it for some reason.
Yeah, I think if you click resubmit, then it will open a clickable
Okay,
version.
thank you.
Yeah.
I'm on the Carolina football team, and we're required to give these to all our professors.
Gotcha.
It's just the update of the university approved absence thing.
Sure.
So you'll be getting notifications whenever I have to miss for like a trial.
Okay, so they don't usually they like give me a printed schedule, but they don't do that this time.
I'm not entirely sure. I think they
It's
just
okay, yeah.
said that it's just going to be all electronic this
Okay,
year.
that's fine. And then do you know about how like quizzes and stuff works with absences and everything?
Like with them,
No, with here. So like if you miss quizzes, it's fine if they're university approved, but then
Yeah.
basically any quiz you miss, like we don't do makeups, so you'll basically you're great on the final.
oh yeah, all right.
Okay.
Yeah, okay, thank you.
Hey, I just have a question on this one. I just was wondering how I was supposed to like code it because I tried like saying that like that first part equaled 6 and then putting in the second part, but then I got that one and I just don't know if that's right.
Just feeling. Yeah.